Hi everyone, and welcome to our ELIXIR Bioinformatics Industry Forum. Today we have a webinar with the topic large-scale cloud computing in the life sciences. And my name is Kathy Lauer. I am the main organizer of the ELIXIR Industry Program. Then I would like to introduce our first speaker of the day, and that's Jonathan Tetz. Jonathan is coordinating the ELIXIR Compute platform and is one of my colleagues here in Cambridge. And he will also guide you through the rest of the program. So please, Jonathan, make us start.
Okay, thank you, Kathy, and very warm welcome to everyone. We're trying to cover a range of interesting aspects of cloud computing in the life sciences today. I'll just do the usual double check that you can see my slides okay.
Yes.
Looks okay, yeah. So as Kathy's mentioned, I'm the coordinator at the ELIXIR Hub, and I work closely with a whole lot of people in a whole lot of places across ELIXIR. And so I'll highlight the sort of executive committee for the compute platform, which is Luda Matejska in the Czech Republic, Tommy Narunen in Finland, Stephen Newhouse based at EMBL-EBI, also here in Cambridge. I thought I'd introduce just very quickly what ELIXIR is, because there will be quite a number of people joining who won't necessarily know. So we are made up of hundreds of institutes, nearly all based in continental Europe, and that there are 22 member states and plus EMBL-EBI, European Bioinformatics Institute, and one hub, which is here in Cambridge. And obviously what we seek to do is coordinate resources across those major hubs and those member institutes in order to advance life sciences. So ELIXIR is an intergovernmental organization that brings together these life science resources. The obvious kind of resources that we combine are databases, software tools, training materials, data standards, and I'll focus here today on the compute resources. So our goal is to coordinate those resources across Europe in order to make life as easy as possible for life science researchers and collaborators. So lastly, before I go into compute specifically, just to give you an idea of the scope, we organize ourselves into 5 platforms, including compute, data, interoperability, tools and training being the other 4. And then you can think about a whole range of communities that we serve and that we recognize through ELIXIR. And though we develop our standards, services and training within these domains as a proof of concept and then potentially as services. So the compute platform itself is all about organizing across these nodes into a coherent platform, again, trying to make life easier for the research-based user. In many cases, those users may well have access to some of these facilities, perhaps at a smaller scale locally or through their national networks. But what we're trying to do is make it easier for everyone to be able to use and deploy this kind of services that we are coordinating on behalf of everyone. So the key activities in the compute platform are around identity and access infrastructure, so-called ELIXIR AAI, cloud, containers and compute resources in general, which enable the analysis, and then an important task around the secure storage and data transfer that makes it possible to do this kind of distributed and hybrid compute. And so in order to do that, we have to manage our relationship with the other European e-infrastructures, in particular in the life sciences. We operate the commission services, and the first one of those that's entering an operational state now is the ELIXIR AAI for identity and access management. We obviously have to keep abreast of the ongoing changes in technology and their integration, and those are driven by our use cases and implied by European and global initiatives. And what we seek to do is keep ELIXIR right at the forefront of that development. So we organize within compute into 4 main areas: the identity and access, data to compute, container orchestration, and hybrid cloud. And we obviously seek to integrate those solutions on behalf of ELIXIR communities and other activities. So the key technology drivers are in AAI, as I mentioned, and that's essential to federate cross-border access. And increasingly, you'll see the value of that work, we hope, to enable national initiatives and global initiatives in cohort work around sensitive data and human data use cases. So we work in particular through wider global collaboration. So we promote cloud standards that we're developing, and we do that through projects such as EOS Live. Sorry, there's a typo on EOS there, which is the European Open Science Cloud, and the EOS Live project brings together ELIXIR and many other European life science partners in developing the technical standards and capacities. And we collaborate with global standard setting organizations, including Global Alliance for Genomes and Health, or GA4GH. Containers are a key way of doing this. So we have a strategic implementation study working in particular with the tools platform on minimizing unnecessary overlaps, basically enabling people to move their workflows in containers in a redeployable fashion across these hybrid cloud endpoints. And that hybrid cloud, that will hopefully enable the kind of project work that's happening through the 1 million plus genomes partners as a highlight of that kind of work. And the data transfers facilitate this load balancing between geographically distributed nodes. So some of the key areas where we focus, some I've mentioned, but in particular around federated human data and through the Global Alliance for Genomics and Health. This also enables the ELIXIR Beacon cohort discovery service for accessing genomic cohorts and searching. And then we play leading roles in some of these Global Alliance technical work streams, including cloud and researcher identity. And by doing that, we can provide a scalable infrastructure on behalf of the nodes for example, in rare disease. And there was a lot of work through a major European funded project called Accelerate in the previous years. And that work goes on now into new projects and new funding. So I'll move on in particular and highlight the Global Alliance collaborations and our leads, our task leads in researcher identity, played a key role in developing these new standards through the Chineke project, for example, in the Global Alliance for Genomics and Health. And they've produced these new standards for so-called Global Alliance passport specification. And ELIXIR and Google were the first two to have implementations of this passport standard. So our ELIXIR AI identity management service is compatible with this even more widely used global passport specification. And then the other thing I've highlighted is this a whole range of work through a global alliance driver project around ELIXIR Cloud and AI. And the key there is to enable federated environments to deliver this large-scale workflow analysis. So we coordinate a range of activity. There's some lead nodes in Czech, Swiss, German, EMBL-EBI, Finland, Greece, Italy, and at the hub, who are all working through active GitHub sites, websites, Slack, and so on. You'll be able to click the links or contact me for more details afterwards. And that work really is focused on particular standards that we're promoting in Global Alliance and in either leading or helping develop and promote. So these, there's a lot of acronyms here, but just to give you a flavor, these are the WES is the Workflow Execution Service. TES is about Task Execution Services, Data Repository Services, and Task TRS Services. So what I think I'll finish with an example of how we were able to coordinate these resources in a very fast response through a virtual biohackathon in the last few months in response to COVID-19. So we played our part. I think all aspects, all branches of ELIXIR played an important role in bringing together all sorts of resources that we help coordinate in support of the work to tackle the pandemic. And so this was about federating existing and emerging platforms and infrastructures, working closely with our partners in EMBL-EBI, who created this COVID-19 portal, which people and researchers working on all aspects of this could utilize. And in our case, you can find a summary of the resources available, so not just compute, a whole range of different resources that were made available. And in particular, I've listed here the particular compute resources. So for example, DEMBI Cloud, which is a federated cloud resource in Germany, and all sorts of other specialist compute services that were made available at short notice in a way that they would never normally be through this work. So hopefully that's given you a bit of a flavor. I'll finish here just with some ideas of some of the areas where we expect to focus in particular in the next 2 to 3 years. And I'll leave it at there for the ELIXIR Compute platform. As Kathy mentioned, please do ask any questions you have as we go through in the Q&A, and we can pick those up when we get through to the discussion sections later. So that's it for my part. And Kathy, or if you'd like to hand over now to the next speaker.
Right. So thank you, Jonathan, for the introduction and for the very useful information. I'm very excited to be here today in this webinar. It's actually amazing how we are still able to do this regardless of what's happening now. So my name is Hatem Navar, and I'm a Google Cloud customer engineer based in London. And I'm part of the EMEA public sector team focused on life sciences and healthcare solutions. So many of you may already be familiar with this statement from Francis Collins, who was the director of the National Human Genome Research Institute in 2005. And he has predicted that most drugs developed will be based on our understanding of the human genome. And we are already very close to seeing this happen. In fact, in 2018, almost a third of the drugs approved by the FDA were informed by our understanding of genomics. Also, there is multiple trends, and one key trend is actually millions of people are donating samples to biobanks and also sharing their DNA information with some of the direct consumer firms. So there is a tremendous growth in the amount of data available to researchers. But this growth in data comes as both a challenge as well as an opportunity. So the challenge is mainly how to handle this huge amount of data in terms of storage, processing, and also sharing, which is a key thing, because what we see is there is lots of valuable data, but sometimes they sit in silos and it's hard to actually combine two of these data sets. So the nature of this data and many of the standard analysis from variant calling to GWAS studies that has to be applied to this data. It requires huge amount of compute, but also has a very bursty nature. So organizations face a dilemma of increasing the capacity, facing high upfront costs to meet this demand, but also risk having idle infrastructure that's not being used. So let's quickly see some examples of organizations who actually manage some of these challenges. So the Broad Institute was one of the early adopters, making the decision to adopt cloud over 5 years ago. And their challenge was to increase throughput, decrease time to results, and meet the increasing storage and compute demands. Today, the Broad processes hundreds of whole genome sequences every day and has over 36 petabytes of data stored on Google Cloud and increasing every day at a tremendous rate. Their journey is also quite interesting, with many lessons to learn from. So for example, when they moved to cloud, they did what we would call a classic lift and shift. So they moved many of what they were doing on-prem to cloud, mostly as is. But as they started to adopt cloud, they started to take advantage of some of the flexibility of the cloud, or some of the options like preemptible virtual machines. Most notably, they actually managed to bring down the cost of running GATK best practices down from $45 when they started to just $5 for a 30x coverage genome. And actually the $5 pipeline is available on GitHub and you can run it yourself. Another example is the Finnish Institute of Molecular Medicine. And it's an example of how an organization took on a huge challenge. So the FinGen project is a very ambitious project that combines both healthcare data as well as genomic data of 500,000 Finnish citizens in a secure environment to push the boundaries of what can be done in research. This not only posed a challenge in terms of compute and storage resources, but also a challenge in how to make this data available to researchers and partners, but also in a very secure manner. So with Google Cloud, FIM and one of our partners in Finland, FIM has built this sandbox environment, which allows access to the data in a secure environment that also allows researchers to bring in their own data to add to the data that's already available in the data set and keep the FinGen data secure within this environment. Also, some of the analysis that they managed to run on a huge scale. For example, earlier this year, they ran a whole genome association study, a GWAS, with over 200,000 individuals and almost 3,000 endpoints, and they actually scaled up to 100,000 cores on Google Cloud. So it's this scale that you can achieve when you can burst and when you take advantage of the cloud resources. So at Google, we're committed to building healthcare and life sciences specific products. So we're not just provide compute and storage, but also provide products, services, and APIs that are designed to cater for the needs of this community. So something like the life sciences API that allows integration with workflow engines, but we also recognize there is a need to be able to mix the different data modalities. So we also have the healthcare API that allows to access and use data stored in HL7 or FHIR format, as well as the medical imaging allowing you to access DICOM systems. And being able to access all of this is key. And we don't do this in isolation, but probably as you have heard earlier, we actually are keen to work with GA4GH to be able to implement standards such as the passport and also focus on other key standards like storage and access. So what do you think would be the barriers to cloud? I'd like you to think about that for a moment. What's stopping you from actually going to cloud? We have been working with many of our customers to help them move their workloads to cloud and take advantage of GCP to run more efficiently and at scale. So I'll try to quickly go through some of the elements that help with this transition, starting by flexibility and being able to optimize your pricing, your cost of compute. So if we look at the example again at the GATK and what the Broad did, one key thing that always I notice is one of the key elements is that being able to shift from a model where you invest upfront in lots of infrastructure to being able to have a real cost per analysis. So this is a true cost per completing a GATK on a 30x average, 30x coverage sample. So you're able to actually say this is the cost per analysis rather than you have hardware cost, electricity cost, cooling cost. So it's very easy to define that. But looking at this example, what happened is, as I said, when they started, their cost was quite high. But then they started to look at the unique features of Google Cloud. How can they can use something like custom instances? So with Google Cloud, you can specify exactly the number of cores and the amount of memory that you have per machine. So this allows you to right size for each part of your pipeline. The other thing is using preemptible instances, using persistent disks, so how you can actually move a disk from one machine, attach it to the next step, so you don't have to copy data. And finally, there was a bit of algorithm tuning. Some of the things they did is working with Google and Verily, they actually managed to get the HTS-cat library to access data directly from Google Cloud Storage, which eliminated the need to move data from the cloud storage to the VM and back. Another key is actually our partner ecosystem. And we have a huge ecosystem of partners that we work with constantly. And this includes different types of partners, from solution integrators and system integrators to providers that provide secondary and tertiary analysis platforms, to workflow engines and open source projects, or specific solutions like PetaSuites or PetaGene that allows you to compress your genomic data. Then there is one other element, which is ability to access data sets. And there are two elements to that. This is a topic I'm very passionate about, because when you look at how things are done today, there is lots of waste. We have exabytes of data that is simply copies of the same data over and over and over again in lots of places. What can you do? What you can do with cloud is actually be able to access lots of this data where it is and not have to copy the data to be able to start making use of it. And this can happen even across clouds. But in addition to that, we actually have a huge public dataset program that include things like the 1000 genomes, the Illumina Platinum genomes, lots of the reference genomes, and actually just I think a couple of days ago, the Broad announced that they're going to put the Nomad dataset on this program as well. So this is actually a more efficient, cost-efficient way, and actually even better for the environment, because not everyone has to maintain this infrastructure to keep a copy of the same data. So also, our infrastructure doesn't rely on any single technology to make it secure. We realize that security and privacy in this field is actually key. So we have designed security on every layer of our infrastructure, from building our own hardware, our own servers, to the physical security of the data centers, to how we manage identities, deployments, and as well as our encryption for all of the data at rest and in transit. We realize this is actually a very key element and area for genomics and life sciences to be able to take advantage of clouds. But don't just take our word. So we actually actively continue to make sure that we comply with lots of the regulations and standards, and not just the international global ones like the ISO 27001, but also some of the more specific local European standards, or even some of the standards that are in a specific country, like the IG toolkit or the DSPT toolkit in the UK. And this is important to enable researchers to take advantage of the cloud resources and know that they're still following these standards and are compliant when they're doing so. So before I go, this is just some of the examples of some of the workloads that we run with our partners and customers that take advantage of the cloud scale. So Hail, for example, is one of the very common tools, and Hail runs on top of Spark and Hadoop, which means it can easily take advantage of Dataproc, which is our managed Hadoop. You can actually start a Hail cluster on GCP using just 2 command lines, and that's it. This means you can start a small cluster, maybe a couple of nodes, just to do your testing, develop your code, and once you're ready, again, with 1 command line, you can scale to thousands of nodes and run your analysis. Also, as I mentioned, with the Life Sciences API, we make it easy and we integrate with lots of the existing and common workflow engines like Nextflow, Cromwell, SnakeMake, and more. And finally, we do realize that sometimes it could be just row compute. It could be simply someone who wants to run a de novo gene assembly and wants a machine with a terabyte of memory and can't have access to that easily. So you can go to cloud, and with just a couple of clicks, you can have this machine with 96 core, a terabyte of memory, or even more. But also, we do integrate with lots of the common tools like Galaxy or Toil from Data Biosphere, as well as the many common HPC schedulers like Slurm and others. So with that, I'm going to hand over to Diana. I hope you're as excited as I am to listen to what Diana and Tony has to say. Thank you.
Okay, so maybe just a little bit of background to Diana. So Diana is actually joining us today from Switzerland. She's based at the ETH in Zurich and works on BiomedIT on secure data and IT infrastructures for sensitive personal data in research. And that, of course, requires a lot of thought about cloud computing as well. So go ahead, Diana.
Great, thank you very much, Kathy. Thank you, Hatem, also for the nice talk, Jonathan, as well. I believe everybody can see now the screen. And I will start with saying that, yeah, I'm very happy to be here. I'm very happy actually to have heard Jonathan's and Hatem's talk. And I will refer back to this in my 10 minutes talk about secure data and IT infrastructure for sensitive personal data and research. So my focus will be today indeed on the Swiss BiomedIT network. And I work myself at the scientific IT services of ETHZurich. And I'm here on behalf of the BiomedIT network. So our goal in the last 2-3 years was to build secure infrastructure, and with this to lower the computational boundaries for research with sensitive personal data. And here, where to build them, on cloud or on premises, is not the #1 question, although it's a crucial question. And we've already seen very good examples from Hatem on how you can run securely confidential patient data in cloud. And we've also heard from Jonathan the direction and the mission of ELIXIR together with GH4GH. So what is driving us here, and I would like to take you now a step back, is exactly this. What is sensitive personal data and what are the drivers? And these are applicable regulations, which can be country-specific laws, policies for sensitive personal data. It's about the legal architecture for data processing and acceptance from the data controllers of such legal architectures. And another aspect I would like to draw your attention on is the full data lifecycle. Security measures apply not only at the data analytics, but also starting from the data collection and ending with long-term preservation publication. And last but not least, an important aspect is data privacy and security awareness on the researcher side. Researchers use secure infrastructure which are provided as services. However, we should not forget about security at the entry point, which are researchers in this case. I can start off with personalized health research use case, because this is our focus. And this is the goal of this personalized health research. The goal of it is to provide the right treatment at the right moment to the right patients. Now, to do this, personalized health research requires health-related data, which classifies as sensitive personal data. And this has references in the various laws of different countries. So what is important to note here is the definition of it. How do you know if the data is sensitive or not? It's usually, and this is a more general definition, if it's relating to an identifiable person and if the breach of confidentiality of such sensitive information has a significant impact on the study participant. So looking at this use case, personalized health research, what is the focus here? So there are 2 points which were already mentioned in the talks before. On the one hand side is data driven, so we need more data, either to increase sample size or to increase the information available for algorithms. And we need more quality of the data already at the collection site, and we need more interoperability of the data. The other aspect that I would like to focus you on is the fact that data in personalized health research is produced outside of the research environment. So we no longer produce this data in the lab. The data are produced at the hospitals or by the study participants themselves with the use of wearable apps and so on. And this means that data has to be transferred. And this in itself is a full topic that has to do with security. We will see in a moment. Now, the trends in personalized health research, and not only, I dare to summarize them in one word. It's about collaboration. So classical biomedical research or classical research with human data usually now starts to aggregate in networks of studies where individual research groups collaborate to form consortial projects that span countries. And the reasons to do that is the same, to increase the sample size, to increase the data available for research. Now, when doing this, data sets need to be combined, and we very quickly come to the point of data fairness. So data need to be available for the researchers in different research institutions to be found, to be available for restricted access. Data need to be interoperable, and so on. With this, we already set the stage for technical and organizational measures which are needed to handle securely confidential data. So sensitive personal data is also referred to as confidential data. We need to do that, so we need to apply cybersecurity measures while handling this data, not only, as I said, at the data analysis stage, but over the full data lifecycle. That means when the data is collected to the data analytic, to the active data management and data analytics stage, and finishing in publication. So note the extent of it and the fact that TOMS, so security, so technical and organizational measure for security, are spanning all of this data lifecycle, and it starts already at the study participant. Have the study participant given informed consent? Is there an ethical approval? Is there a contract to transfer the data from a hospital where data is produced to the researcher, be that on premise or on the cloud, and so on. Another aspect important to note here are the roles. What is the role of a principal investigator or project leader in here? Is it responsible and accountable for the full data lifecycle? And what are the roles and the responsibilities of the users, so of the researchers? This boiled down, at least in our case in Switzerland, to a quite new ecosystem. So we needed to build up new secure data and IT infrastructure in a research environment. And of course, the question here as well was, is it going to be on premise, on the cloud, on an academic cloud, or on a commercial cloud? But finally, the need here is to build secure and versatile and user-friendly data and compute infrastructure that are secure. And the novelty of this ecosystem are not the modules, the legal, ethical, the IT infrastructure services, or the usage itself, but is their combination. So we've already heard before, to make use of these data silos, to mitigate data silos, to make use of the data, we need first to know which rules apply. Then we need to have available distributed large data lakes to feed the algorithms on. We need to make use of data centralization or edge federation. And we need, of course, the compute power, which can be very well provided in the cloud, in hybrid, HPC, or federated. Finally, what we need to provide to the researchers and clinicians, they need a readily accessible environment that is user-friendly for them, either to run compute analysis or to explore data in a secure environment. So in Switzerland in 2017, we launched the Swiss Personalized Health Network, which is an initiative that aims to build infrastructure for securely handling confidential data, health-related data. It is a decentralized approach. It is not building up on increasing the silos, but rather leaving the data at the producer and using it in a project-specific manner. It pays specific attention on the FAIR principle, and it builds up a lot around interoperability of data, on semantic harmonization, on technical interoperability with containers, workflows, and so on. So the BiomedIT network in Switzerland is built specifically to support in a first phase this SPHN-funded project, and it's a secure infrastructure that is building up on 3 regional nodes in Switzerland that are about building up together a mid-sized compute center, and they have security as usual at different layers, starting from the data center itself, on a data storage, access management, logging, monitoring, and so on. The BiomedIT network facilitates transfer of data from the different data providers in Switzerland and exposes a research environment for clinicians and researchers that is secure. Maybe very briefly, to give you an overview of an example of such a node in the BiomedIT network is the LeonardMed platform provided by the ETHZurich. So it's a multi-tenant system that provides CPU, GPU compute. It provides access restricted to the data and provides a wider range of machine learning and bioinformatic tools. While the whole activity on the system is logged and monitored, the data is separated per project and it's encrypted at rest. So I'll go a bit quickly through this part, but what is important to note here is that back to the BiomedIT network with the 3 nodes, is not only building on infrastructure, on how to connect these 3 data centers, but it's also building up on the processes, how to include regulatory framework into the whole operation of the platform, how to reconcile with data transfer from various hospitals towards a research environment, and ending up with providing such secure compute environments for users. The challenges we have encountered along the way mainly spin around trust, building trust at different levels, building trust at technical levels between the 3 data centers and the incoming data flows from hospitals, building trust at operational and at organizational level, with especially this building up this legal architecture for data sharing, controlled data sharing. And the other major challenge that we are facing is, of course, interoperability of data and of workflows. Now, to come close to the take-home messages, and I will not insist on the slides that I skipped because I believe the slides perhaps will be made available. The take-home messages from my side before I leave is to bring you back to the spotlight on sensitive personal data. It's of paramount importance to know which data classifies as sensitive and thus needs security measures, and which data is open access. I've been speaking here about a spotlight on personalized health. However, this is a generalizable case. Any research with confidential data is amenable to the same security measures. And this is happening worldwide as well as in Switzerland as we speak. So we've heard before, we also heard from me that sensitive personal data does require technical and organizational methods like the BiomedIT infrastructure, like the secure cloud that we heard before from Hatem. And first of all, it's also important to remind that this is a new and in development ecosystem. So everybody's learning how to implement what is written in each regulation and laws of each country, and how to integrate this with ever-growing requests from the research side. Whether or not it's a secure cloud on-premise, commercial, academic, they are all suitable as long as the choice is driven by the applicable regulations and rules. And we all see that the direction goes here into raising data privacy and security awareness as a modus operandi from the infrastructure to the users, which are the researchers. So with this, I would like to thank you for listening. Thank you for your attention. I would like to thank Katrin Kramery, Director of Personalized Health Informatics at the Swiss Bioinformatics Institute, and to the Scientific IT Services and the Leonard Med team. Kathy, I pass back to you now.
Thank you. Thanks very much, Diana. For our final talk from the panelists, before we go into more question and discussion, we have Tony Wildish, who's the lead architect in cloud bioinformatics at the European Bioinformatics Institute. And he's going to tell us about migrating EBI into the cloud. So over to you, Tony.
I'm going to be talking about do's and don'ts and lessons learned from migrating EBI into the cloud recently, some of the ideas and misconceptions we've had, and just some of the things that we've learned. So second slide, please. Thank you. So why would we bother migrating EBI into the cloud? Well, there are 2 significant drivers. One is that our data is growing exponentially. It's doubling every 2 years. So with that kind of data growth, it's very difficult to cope on premises with the volume of data. I'm now seeing slide 3, not slide 2. Okay. The other driver is that exotic hardware like GPUs, high memory machines, these are difficult to utilize well in an HPC environment. They tend to be oversubscribed and underutilized and hard to use well. So moving on to some of the things that we've learned. Number 1 here on slide 3 is that a lot of people think cloud is easy or cloud is hard, and where is the reality? I'm now seeing slide 4. Can we stay on slide 3, please? Thank you. So a lot of people see cloud as being easy because you can get anything on demand. You just click a button and you get anything that you want. There's basically infinite resources behind it. On the other hand, a lot of people see the cloud as hard because now you're the sysadmin. You're responsible for everything happening on the cloud. You have to configure your network, you have to configure your firewalls, your security rules, your access ports, users, update security, and you have to watch out for the costs. The reality there is that all the cloud really does is move complexity around. Complexity in an HPC center typically rises with the number of users, and you can find that out easily enough just by asking someone to upgrade a version of a piece of software on your HPC cluster. It'll typically be a nightmare because it'll take a lot of people to agree on the upgrade. Whereas with the cloud, the complexity comes down on the user individually. It's effectively per user rather than shared across a group of users. So the complexity is still there, but it's manageable, it's more fluid, you can put it where you want it. If you want to go for infrastructure as a service, the basic level of service, then you put the pieces together yourself and you manage all the complexity. If you go for platform as a service or software as a service, then you end up with a more managed environment where you have less direct control over the nuts and bolts, but you don't need it because the system does what you want. You'll have seen in Hatem's slides that he's pointing out that Google are putting together a lot of high-level services, software as a service, platform as a service, specifically to try to hide some of that complexity while still giving you the things that you want. So basically, you choose. Either you do it yourself, or you file a ticket and wait for someone else to do it. If you do it yourself, you have to learn how to do it yourself. Your call. Next slide, please. So when we started our cloud journey, we decided we wanted to be cloud agnostic. It sounds very laudable. You want to avoid vendor lock-in, make your applications more portable. You want to be able to move to where the costs are cheaper. But again, Hatem showed this beautifully. Commercial clouds diversify themselves as much as they can to distinguish themselves. So it's not always easy to compare offerings between different commercial clouds. They don't all want to offer exactly the same things conforming to exactly the same APIs, because then they'd be competing on price and you'd be just squeezing the margin. They want to distinguish themselves by offering something different. So if you're going to be truly cloud agnostic, you're going to go to the lowest common denominator. Next slide, please. So 3 more clicks as well, please. So the lowest common denominator, if you look here, we have sets of icons from 3 or 4 of the clouds. One more, and you can see that these clouds are offering a large number of services. So what is the lowest common denominator if you look amongst all these? I mean, these aren't even the full set of services that the various clouds offer. This is Azure, AWS, Google, and IBM here. So what is the lowest common denominator? Next slide, please. Lowest common denominator is, yes, you've guessed it, it's you. But rather than trying to be cloud agnostic, a much better approach is to use cloud-specific tools wherever that's appropriate, adopt a cloud-native design, keep your designs modular, containers, microservices, and design for horizontal scalability. Then your architecture will be portable. Your actual code might not be, but your architecture will be. You'll have an architecture that you can deploy in several clouds. So then, of course, you need to make sure you document your architecture, which brings us to the next thing that we've learned. Next slide, please. Well, that is, don't write documentation. There are many people who think that if it isn't documented, it doesn't exist. But the thing about documentation, it's invariably out of date very easily, very rapidly. It's typically wrong, out of date, as I say. And even if it isn't, it's normally just too boring to read. People won't bother reading it if it's more than a couple of pages long. So rather than writing documentation, write infrastructure as code. Document your infrastructure by writing it as executable code. Scripts, Terraform, or cloud-specific tools like the G-Cloud API, G-Cloud CLI for Google. These allow you to write scripts that will build your infrastructure for you and deploy your application in it. And this is your best documentation. So portability then becomes a matter of translating one IAC representation from one cloud to another. And this is much more straightforward and easy to do. Next slide, please. So another thing that we've learned is that everything is a process. Nothing is an event. Everything is a process in that whatever you do in the cloud, you'll end up doing it again and again and again. Nothing is ever finished in the sense that you walk away from it and forget about it. New versions of software get released, new versions of products, new products come out, which make older ones obsolete as the technology evolves. So a few years ago, for instance, if you went into the cloud, you'd have virtual machines and only virtual machines. Then containers came along, chance to refactor your architecture and use containers for more efficiency. Now containers are starting to be give way a bit to serverless, Lambda functions, cloud functions, where you just write a piece of code. You don't even need to build a container for it. So the technology evolves considerably, and you want to be able to evolve to keep up with this. So everything you do will be a process. Having your infrastructure written as code, infrastructure as code, makes this much easier because you can actually keep up with things a bit better that way. Next slide, please. So as a result of that, follow on from that is if everything is a process, then production mode doesn't exist really. So don't use the P word. Your development cycle is your new release and maintenance mode. What you do in development, what you do for maintenance should be the same as what you do in production. There shouldn't be some big monolith that gets bundled together, signed off, and put into production, and then you work on the next production release. You need to design in such a way that you can update your production deployment live in front of all of your users without them noticing anything going wrong. So instead of asking things like, how can I make a production release, ask yourself things like, how can I replace just this piece of the application or just that piece of the application while the thing is still running? So use cloud native technologies, infrastructure as code, continuous integration, continuous deployment, rolling deployments, all the sort of cloud native tools that one hears about. Use these such that you can actually roll out your application piecewise while it's running and avoid the concept of a big scale integration on production mode. Next slide, please. Okay, the next thing we've learned is think big, start small. Small deployments are worthwhile because you don't spend too much while you're doing it. You start small, you start practicing with a thing. But small deployments can't teach you a great deal. If you want to start seeing how to optimize your cost, optimize your efficiency, how to really test your ability to scale out or to scale longitudinally, you need to do much larger deployments. So you need to be able to start running things for a long period of time, using the technologies to scale out so that you can start seeing the benefits of using things like reserved instances, tiered storage, things like this. So this is part of the journey of cost optimization. You don't want to start scaling out to 1,000 nodes instantly because you'll be spending an awful lot of money. Hatem showed a very nice example of the Broad Institute optimizing their costs. They started with a lift and shift, which cost them $45 per genome, and with just 5 interventions, got it down to $5 per genome. 4 of those 5 interventions were just related to how they used Google Cloud, when they were not interventions on their pipeline. Only the last one was an intervention which actually touched their pipeline code, and that was at a fundamental layer underneath it. So the actual algorithm stuff wasn't being changed at all. Several ways in which you can tune your application. Again, it's a process that you go through, a long-term process, something that you iterate over, improve the performance, reduce the costs, see how it runs, measure it, rinse and repeat, keep on doing that. Next slide, please. I'm not seeing the next slide. Okay, yes, there it is, thank you. So again, if you're scaling up, you'll soon find that data flow is much more important than workflow. A lot of effort is put into workflow management and portal workflows, how to run your workflow in the cloud. But relatively speaking, the compute is fairly easy. There are many options for cost optimization. There are many well understood ways of refactoring and adapting workflows to be more efficient. Sustained use discounts, spot markets, things like that. Going from virtual machines to containers to serverless functions. There are many tools out there which will help you monitor and advise you on the size of the thing you need. Can we go back to slide 12, please? Actually, slide 13 now. Kathy, can we go back? Thank you. Yes, data, on the other hand, is much harder. You can't turn it off to save money. If your data is in the cloud, it's going to cost you money whether somebody's using it or not. The classic argument for saving costs on data is to use tiered storage. So any data that you're not using should go into the cold storage, cold archive, deep archives. Problem with that for EBI is, if you recall the second slide, our data is doubling every 2 years. So half of our data is less than 2 years old, which means that the chances are that half of our data is still going to be active, still being used in open research projects. So it's very likely that half of our data, at least, will not be able to be put into cold storage anytime soon. It's also much harder with data to estimate the costs when based on data movement. Unless you actually know the data usage patterns and not just the actual details of the workflows, who's going to download your data, how often they're going to do it, things like this, it can be very hard to estimate the costs of data movement compared to estimating the costs of compute. Slide 13, please. So let me summarize then. Basically, our experience shows us that if you want to move the project into the cloud, you should get started however you can and establish a process of iterating and improving. Lift and shift is fine to get started, but it's not cost efficient in the long term. Again, Hatem showed you can get your costs down by a factor of 10 in some cases. It's well worth continually iterating and improving, establish the process. Go cloud native. That process of improvement should take you to cloud native architectures. Use all the various tools and techniques and technologies that are available to support a cloud native workflow. Try to build data flows rather than workflows. If you think about where your data is sitting, where your data is moving, what you're doing with your data, then this is the key to optimizing the cost and the efficiency of a workflow as the workflow scales up to massive scales. You can always go for a faster algorithm, a more efficient algorithm by cutting corners or using heuristics. But if your data is a few petabytes, it's a few petabytes, whatever you do to it. And related to that, of course, the thing that drives a whole lot for me is that everything is a process. Try to look at everything as being a process of moving things on, establishing things, getting things done, and then doing it again. So basically, expect things to change far more frequently than you're used to in the past, much more than they do on an HPC system. Next slide, please. So the one cheat with all this, I'm talking about migrating EBI into the cloud, but of everything I've said, pretty much none of that is in fact cloud specific. Any of it, all of it, could apply to pretty much any software project in the last few decades. All of those same approaches, modularity, clear interfaces, separate things out. These work just as well in an HPC environment. We have people who migrate projects into the cloud and are concerned that they will then not be able to run on an HPC cluster anymore because it's now cloud native, but this isn't true. You can use the techniques and the technologies on an HPC center just as much as in the cloud. The main thing that makes a difference here is the speed of the change that you're dealing with. You're now dealing with very rapid change, much more than you used to. And the best thing you can do is to try to adapt to the speed of that change, because if you can achieve that, then you'll avoid a lot of issues with legacy software. We have a lot of legacy stacks at EBI, stuff which was written 10, 15, 20 years ago, which is still being run. Nobody knows how to change it. Nobody knows how to upgrade it. But if you adopt a full cloud native approach, you can deal with that. So basically the way to do this is to redefine your scope of your application. Instead of just thinking of your application as being your code, think of it as being your application and your infrastructure and your cloud platform all together. All of these things together, your code plus how you deploy it, how you run it on this cloud, these form your application. And this is the thing that you can maintain and evolve for the future. So on to the last slide, please. So when it comes to looking at the speed at which things change, There's a quote I found from this guy, Paul Virilio, who's a lesser known philosopher, who really sums it up in a lot of ways for me. You can adopt new tools and technologies, but you also have to think of the consequences of adopting them further down the line. In a typical HPC world, we don't do that, which is what legacy code means. This is why we have legacy stacks, things that hang around that nobody knows how to do anymore, and nobody knows how to run anymore. So if you adopt a cloud data design, then maybe you can invent a pipeline without inventing a train wreck at the same time. And with that, I'll hand back to Jonathan or Kathy.
That's great. Thank you, Tony. I certainly recognize some of your lessons from some of the projects I've been involved with over the years working on cloud. So we've had a really nice selection of, I hope you'll agree, of perspectives, a nice selection of perspectives across cloud computing. What we're now going to do is a change of gear, and we just have 3 questions for you in Mentimeter. So I'll hand over to Kathy, who'll run through that with us, and then we'll use that. We'll ask our panelists to reflect on the answers to these 3 general questions, and then we'll, any time remaining, we'll try and feed in other questions that have come in during the session. Kathy.
Yeah, so as Jonathan has already said, if you have a look at the screen, it will tell you the internet address you need to type into your browser and the code. So yeah, if everyone could just answer our first question now, so we get a better understanding what our audience is. Do you use cloud computing in your organization or company? So we'll wait a little bit longer for more answers to come in. We have over 100 attendees on this call, so we should get a couple more questions in, a couple more answers in before we hand over to our panelists. Could I just remind our panelists to share their cameras again now? Right, okay, Diana, Tony, and Hatem, all there. Great. So we can already see that many of our attendees are using cloud computing on a regular basis. So it's probably not particularly surprising.
Mm-hmm. I think we've got enough answers. We'll continue. We'll leave it open for now, but I think we can start to have any quick reflections across the panel on this. I mean, I assume not too many surprises for people, but perhaps if we go to, let's reverse the order. Well, let's go back in the order we were. So Hatem, perhaps first of all, any thoughts on what you're seeing here? Does this relate to your experience?
Well, it does. I think what I see is lots of organizations. So as you can see, there is lots of organizations who are already on cloud, but what we see every day, lots of organizations who are actually want to make the transition, but either are hesitant or find barriers to moving. So it's quite interesting to see this number. But there is, of course, lots of, first of all, investment in the local hardware. And that sometimes could be in itself a barrier, because you have what is sometimes perceived, at least for some researchers, as free resources, because they don't basically pay for it. There is someone else who's taking care of all the infrastructure. But there is definitely an appetite for adopting cloud, be it for speed of execution sometimes, or be it just for the scale.
Yeah. Diana, any thoughts on this one?
No surprises, but it would be interesting to know the domain, because if you think about it, so in research, of course, you can have research infrastructure that provide cloud infrastructures, right? And it's interesting to know if this the audience is more, it's life sciences, but which of the domains, because the use cases are rather different. So as long as you can run analysis on a server, on a desktop server, you would for sure not make the leap immediately to the managed cloud services. But other than that, I think, yeah, the numbers are expected.
And then, of course, you have this huge spread within domains such as life sciences as well. You know, at the one end, you might have genetic epidemiologists who are going to be busy with high performance computing already. And then, and it's interesting actually to know to what extent they are able to move into the cloud yet, or feel they are able to move into the cloud. And then obviously you've got the many hospital healthcare facing research projects where it's mostly Excel spreadsheets at the moment still, and longitudinal questionnaire. Okay, Tony, any just quick thoughts on this one? We've got about almost 60 answers now.
Yeah, the thing I find interesting here is the pink and the blue together, people who are using cloud computing and the fraction of them that are having problems. It's about 1/5 of companies, groups that are using cloud who are having significant technical problems enough to outweigh the benefits. Yeah. I would be very interested to hear from those people to find out what the technical problems they're encountering are, find out if there's any commonality between them, if there's anything similar to the stumbling blocks that we've hit on our journey into the cloud.
Yeah, I do wonder as well, actually, if some of those, you may have a perspective on this, are they may have had a technically minded person in their given group. Perhaps that person's now moved on, having set up on the cloud, and you have this difficulty of the skills as well, retaining skills in a given group, working on the cloud. Yeah. I guess, I don't know, it'd be interesting, just before we move on to the next question, Hatem or Diana, any thoughts from you on, do you think we're making it easier now for a normal, let's say bioinformatician to work on the cloud on your, on your resources? Do you think we've moved a long way now, and hopefully that fifth will get smaller? Hatem first.
I think definitely things are moving in the right direction in terms of, I think there were scarce documentation when this whole thing started. So now there is not just documentation for how to use cloud, but I find it every day that there is a growing number of documentation and tutorials that actually explain specifically for bioinformatician. The other thing as well is tools that use cloud in the background without much change to the way researchers are used to use. So workflow engines is a very good example of that. Many researchers have used workflow engines for a long time. It's mainly a different configuration file, but you run your same module on Cromwell, or you run your same script on Nextflow. So it's making it easier to make the leap, because for the bioinformatician, the setup is not much different, but there is a need for the skilled person who would actually help him build that setup. But once it's done, it's mostly smooth sailing.
Mm-hmm. Okay, Diana, you'll be first to start reflecting on our second question, which is open now, which is going into more specifics on what are those bottlenecks. And you can see that we already have about 30 answers, just under 30 there. So yeah, over to you.
I'll jump onto my domain. I will leave the technical barrier and awareness, because I think Tony and Hatem will have definitely something to say there. Regulatory restrictions, and yes, I focus on that. I think this is an important point, because it's true, as long as you can and may use a cloud for processing, now I go specific on the sensitive personal data and confidential data, then you still have to go to the technical barrier, to the awareness, organizational culture, and so on. So I'm not surprised that these 13% contributes to the answers. It's very diverse. So I think as long as, for example, at ETH in Zurich, sensitive personal data is not permitted to be stored and handled in a cloud. At the moment, things may change, and we also know that security in cloud is definitely there, and Hatem showed already Google Cloud Platform. It has all the ISO and many certifications specific to several countries. However, even with this, you have specific data institutions and data providers who will not still, at the moment, release the permission to use data in clouds.
Mm-hmm. Thank you. Yeah, any final thoughts on this one before we move on to the next one? In some ways, it's almost surprising that the regulatory restrictions are perhaps the smallest. But in the interest of time, we should probably move on to the third question, if that's okay, and then by all means refer back to those second question answers as well. So the third question was, have you received any form of formal training on how to use cloud computing? Any thoughts from you, Hatem, perhaps while we wait for the new answers to come in?
So I was actually surprised that regulatory was only 12 or 13%. I expected it to be a bit more because it's definitely one of the barriers. I think can you go back to the previous question, or is it too hard? This will stop the process. Okay.
Yeah, no, it's okay.
The funding constraints is an interesting one, because as I started working with universities and research institutes, there was a funding constraint, not as the funds are not there, but as the funders do not understand how cloud computing works. So sometimes the funds includes a line item for hardware to be built, and that's not how it works in cloud. So this was a challenge, not in terms of there is no funding, but in terms of how the funding works and the conditions that are attached to that funding. I think looking at the results, there's certainly some room for improvement for all the cloud providers, certainly us, in terms of how can we help with the technical skills as a barrier, and as well as the awareness. How can we make sure that people have access to more training, which relates to the next slide, I guess. And it's certainly one of the things we are working on, as well as organizations like yourself and others in this field. There is lots of effort in terms of educating and offering more training as well.
Okay, so thank you. Let's move on to that third question and see how many answers we've got now. Okay, we've got a good number, 42. I'll come back to Hatem to Diana in a second. I was just going to make a comment that, based on my experience certainly, and others come in, Tony and others, I think often the funding is not very clear either. So funders may not understand, but also total cost of ownership is not well understood inside typical research institutions. In other words, they may see an upfront cloud cost, but they're not necessarily comparing that to the real cost of their current inside provision. So, you know, all these things come into play. Okay, Diana, would you like to comment on the training side of things and what we're starting to see?
It's quite encouraging to see that 46% are self-taught and make it to use cloud compute. Means that the barriers are, you know, not that high. Yes, I think it's necessary. So it's necessary, first of all, using the cloud, but then using the cloud for your use case. So we mentioned before, bioinformatics, you either have standardized workflows, which are pretty straightforward. If you have them in a container, it's relatively straightforward for a new person to onboard. But whenever you have to do method development using cloud infrastructure, here I think that there would be a benefit from having a bit more dedicated training or onboarding on people onto this. Yeah.
I know Tony has a lot of experience in training on the cloud side. What are your thoughts on this, Tony?
Yeah. We put together a training course at EBI last year, and were quite surprised at the level of demand. We ended up training 150 people at EBI itself in 6 sessions, and then giving the course remotely, once over the web and once in Berlin. So there's definitely a lot of demand for people to get the basic skills. But what we've noticed is that the developers want these skills, but quite often the management don't prioritize the time it takes to actually get these skills. They want to see the results, getting something done, but the time it takes to learn how to use cloud is seen as some sort of unnecessary overhead. So in fact, I was very interested in the previous question, where awareness stroke institutional, I forget how it's phrased, institutional culture was an issue, and I would be very interested to know the split between awareness and institutional culture, because I think quite often the culture can be a bigger problem than the awareness. There are clearly a lot of people who want this technology, want to use this technology, and simply need to find a way to get started in it.
Thank you. Good. Any other final reflections on that, on the points we've touched on there? We've got about 10 minutes, so what I suggest we do in the last 10 minutes is we'll just take a look at some of the questions that have come in through the Q&A. And there's a few different ones, so we'll skip my one in the interest of time. Let's go into Hatem's talk. Olivier Salou was asking how public data sets are stored. Are they object S3-like or POSIX accessible?
Okay, so a quick answer. So they're stored. There are two types of public data sets. Some of them are stored as object storage on Google Cloud Storage, and the others are in the form of BigQuery. So it's in tabular format.
Okay, thanks. And then there was also a question for Diana here. This was Henning Hupchikov. On slide 7, he says, I think, decentralization and data stays with providers was emphasized, but he was seeing that the systems shown in about slide 12 seem to be more or less centralized, though with 3 nodes. So actually, I think that's a question for Diana, isn't it? Sorry.
Yes. Yeah, I think it's a very good catch, and it's a very good point. Of course, when we started, we also had in mind, like everybody, mitigate data silos. However, we hit very quick the reality. At least in Switzerland, it was already a big step forwards that hospitals agreed to trust an academic new research infrastructure to send copies of data. And you're right, you send them centrally. At the moment, we do compute centralized. We are not ready to do federate edge compute, out of various reasons. So some of the algorithms are amenable, so you could technically, mathematically do it. Not all of them, but the biggest problem that we encountered was the data harmonization. So even within a hospital, data are not harmonized. And now, let alone crossing different hospitals in Switzerland with different languages we have here. So it's true that the SPHN goal is to do a decentralized approach, but we have to start somewhere, and we started with this rather centralized initial phase. What we do focus on is how we handle the data. What is the process of data being transferred, used, and returned to the owner? And we tried here to streamline so that the next project who comes in does not have to copy from A to B again, but it can make use of the pre-established processes before. Of course, we think in future to have the federated edge compute, so to send the code that directly to the data exposed at the hospital, but still within a hospital network. However, this is, we see it's a major challenge. It's technical, it's organizational, and it's also cultural, because we came to the cultural adoption of cloud. This is yet another cultural barrier that we have to cross.
Yeah. Okay, I'm going to quickly answer just the questions that I have on my talk that are just very quick to answer. So Arnold Keol asked if ELIXIR AI and EduGain are somehow related or integrated. Yes, basically ELIXIR AI is built on top of that EduGain standard, amongst others. So that's one of the things that makes it more easily integratable with various services that we enable access to across ELIXIR. They also asked about whether public data sets are available on European nodes, or Arno asked about that as well. I don't have an answer for you specifically on GCP, which you were asking about, but we have a whole set of, I mean, the default in EMBL-EBI, for example, is that data where possible are made public. And what we do in the compute platform is deploy technologies that enable you to run analysis using these core data sets, so-called core data sets as we define them, and that you have an access to those directly at the places where you do this high-end compute. So we have a sort of peer-reviewed set of core data resources where you can run your analysis and potentially run your own data against and perform correlations against those so-called core data sets. Coming back, the next question was to Hatem from Bez Mumbani, and asking what about the updates or version controls of the tools available in the platform? And then his second, yeah, I'll let you quickly answer that one.
So I would go back to something that Tony mentioned, which is that most, and as well as Diana, that most of the tools that we are using today in the bioinformatics are actually container-based. So the versions of the tool are based on the containers. We do have a very well documented process for when we move from one version to the next. There isn't really a version as sense in the products, but we do maintain backward compatibility, for example, for APIs and stuff like that for a number of years. So I don't see this as an issue.
Mm-hmm. Okay. And then Michelle Vidotto was asking, do you have an idea on how well SnakeMate Workflow Manager supports execution on Google Cloud?
So this was just released very recently, a few weeks ago. I've just tested it on a small scale. I did help work with a researcher who was running large-scale SnakeMate pipelines with Kubernetes. So we used the Google Kubernetes engine instead. So that's, please give us the feedback. And we are actively working with the developers. So it would be good to hear back from you.
Okay, and then for Tony, I'm just checking the time. We've just about got time for another couple of final questions. One question was from Tung Yung Gayan, who is asking, our application is being migrated to web production Kubernetes, which is considered a custom cloud platform. It seems to work fine, except for some issues that could be resolved if we deploy it on public cloud like Google. So I think they're trying to see where they should use the different platforms. You know, where does public cloud come in and where it doesn't. I'll let you answer that. Yeah.
Well, without knowing what the sort of problems he's seeing, I couldn't really give a clear answer to that. And since this one's a bit EBI specific with the web production platform, I suggest you drop me an email and we can take up that conversation. But yeah, this is one of the points. You do have a choice of platforms that you can use. I know that our web production cloud EBI is locked down a bit tighter than some other clouds, simply because we allow access to internal EBI data. So there are restrictions which can sometimes make it harder to get hold of the things that you want.
I think it's yeah, a good point. I think it's probably worth making the point that these wide collaboration projects such as EOS Live, they actually have specific elements of them which incorporate use of public cloud alongside other resources. And of course, many of the nodes will be using public cloud in order to provide their services also. So there's a real range of hybrid answers to this one, as well as hybrid clouds. Okay, we're just about coming up to time. We do have a set of general questions as well. Can I draw your attention? I don't think we're going to have time to follow up all of those general questions, so apologies for that with everyone. We will make as many of the resources shown today and shared with you as possible available to participants in the follow-up. I draw your attention also to the handouts that we provided with this from ELIXIR. There's a nice recently updated brochure on ELIXIR's compute platform and its some of the recent implementations. There's also a nice one on the industry program in ELIXIR. Can I thank all of our panelists in particular for their contributions. I'm sure they'll be happy to take follow-up questions after the event. And over to you for any closing thoughts. So Diana first.
It was great. It was really great listening to all the talks, and also actually it was interesting to see the answers from the participants. So I'm looking forward to see how we come to the synergies, to what we do in Switzerland together with ELIXIR GH4GH. I'm very curious myself on the development on the commercial secure private clouds. And I very much enjoyed Tony's insights from the experience of migrating this to the cloud, ABI to the cloud. So thank you very much.
Hatem?
Yeah, thank you. It was really great to listen to you, Jonathan, and to both the talks from Diana and Tony. yeah, it's a very exciting time to be in this space, and I hope that actually cloud can play a role really in what we can do next in it.
Good stuff. Tony, any closing thought for you? Have to be quick, I'm afraid.
Yeah, well, again, thank you to the other speakers. This has been a very interesting event. To me, the thing that shines today is that there's a lot of people who want to get started in cloud and are trying to figure out how to do it. There are an awful lot of training materials out there that are cheap or free, and it's not difficult to pick them up. So I'd say just go for it, get started, throw yourself in the water and sink or swim. I'm sure you'll find yourself swimming.
That's a good place to stop. So thank you, everyone. Thanks again to our panelists. I'm very grateful for your participation. And thank you very much to our organisers, Kathy and Genia in the background, who've done a lot of work to set this up and make this happen. So thanks to everyone, and we'll talk to you all soon.